So I've git cloned apple trees, brought it down to my local right here. There's multiple files. We have multiple spec files. We have this runner file, which we're not quite sure what it kind of does. Yeah, we may have seen it in one other challenge. It's the first time we're dealing with multiple classes, and we have this test spec file that already has a bunch of test specs written, and we're supposed to pass all these test specs. So I'm gonna open up, look at what we have to do. Learning competency modeling systems with objects. So previously we've just been dealing with one class and just manipulating writing methods on one class. really haven't been utilizing multiple classes with one another. And so I work with objects in Python, use instance variables and accessing instances variables effectively. Great summary. So raining Washington grows apples. Fun fact, on average, Washington State grows 125 million boxes of apples per year. At 40 pounds per box, that's 2.5 million tons of apples. Let's create a toy program to model an apple tree growing over the years. We plant the apple tree, wait for it to bear some fruit, and then pick all the apples as soon as it does. The tests on our apple tree spec file show how all this might work together. So if you think of apple trees, so we're building a little application that has two classes, and one class is integral into another class. Think of it like a school. You might have a school class, and within that school class, there's a student class, and you can access all the students in the school via the school class. So here, same thing. We have an apple tree. It's a bigger object. It's like a bigger, it holds everything. And then we have like the apple, like the small apple class, and we can access all the apples on the tree via the apple tree class. So implement the apple tree and apple classes. Set up your apple tree and apple classes with the appropriate attributes. You'll need to be able to call tree height. So it looks like we need a height attribute and an age attribute. Doesn't look like these attributes are invoked, so they're probably instance variables because they're not invoked instead of instance methods. Respectfully, what other attributes might your class need? Use the code in the runner file to guide you. Write tests to make sure your class is working the way you expect it to. So I've got this apple tree spec file. I'm just going to comment all this out. I'm just going to look through that spec file to see what else we need. So apple tree, all right, here's the apple tree class. Here's an apple tree instance. Apple tree.age equals 0. So here's that instance variable. Apple tree.age tree. So it looks like we need an age tree method. And so when we age the tree, it increments the tree age by 1. Cool, let's go ahead and comment that out, and let's try to get that test passed. So here's my apple tree class, and my apple class. I'm gonna move this over here, test spec file there, delete that. So what are some attributes we need based off of what we just said with regards to age and like the release one? I heard we need age and height. Self.age equals 0. Self.height equals 0. I'm going to clear this. I'm going to ls cd apple trees, ls python. I'm going to run this apple tree. Wait. Is it the apple tree spec file? Yeah. Yeah, I want to run this apple tree spec file. Apple tree spec file. So I commented out all the tests except for the first one. We ran one test, failures 1. Traceback, always read your traceback file, Apple tree spec, line 13. So right here, in test age tree, apple tree.age should equal 1. Here's the actual output when it's expected to be this. So 0 does not equal 1. In here, in our test spec, we have an age tree method, so we need to call that. So maybe in here is where we'll actually increment our age every time we want to age the tree. So we can just do if self.age plus equals 1. And then, yeah, I guess we don't really need to return anything. We can always just return the self.age just down here. I'm going to clear in the console, a terminal. I'm going to run that again. 1 test ran, 1 test passed. Great. So undo test 2. When you age the tree, its height increases. Apple tree, so it creates a new instance of apple tree. Original height should equal 0. Then also when we age the tree, it should increment the height as well. So apple tree to height. So it's greater than the original height. Okay. So in here we do self.height plus how high do you want it to grow? I'm sure I know people like
2 feet a year.
2 feet, so like 2. It's great. I know.
I think there should also be a clause that if it reaches a certain height and stops growing, it's kind of be 200 feet.
Okay. Well, these are modified, genetically engineered trees that just keep growing forever.
The Google says they grow to be fully mature by 20 to 30 years.
Okay. Okay. So let's implement that logic. If self.height or self.age is greater than, or should we do less than 30? Height plus equals 2. Does that make sense? Return. What do we want to return? We can just return the age again. So clear. Run test 2 now. So 1 and 2 are going to be running first test, which should pass. We really haven't changed anything. And we're just implementing some logic. If the age is less than 30, it's going to continue to grow. Any questions so far? All right, 2 tests ran, 2 tests passed. Making some headway. I'm going to just go back to the releases, age respectively, attributes you might use, write tests to make sure, okay. As a tree ages, it grows taller. Eventually, it starts bearing fruit and stops growing. Not necessarily at the same time. Some years later, the tree dies and can bear more, or essentially can't bear any more fruit. Implement tree age. This is what we're doing here. Each year, the tree goes, get some amount taller, and eventually stops growing. So we did implement that logic right there. You can decide when the tree stops growing. Later, it should die. All right. Okay, have a height attribute, which returns the tree's current height. Have an age attribute. Have a tree method, which we did. Then have an isDead method, which returns true if the tree has died. Where should we, so I see up here it says the tree should get some amount taller and then eventually stop growing. Later, it should die. At what point should it die?
In the class is that if the age is equal to or greater than 100.
Well, this only tests, which returns true if it has died. It doesn't actually kill the tree.
Well, it said variables say stuff that alive.
Okay. Yeah. Steven said, we can set an instance variable called like self.isDead or is alive. Let's do isDead.
Well, because that would be the name of one of those methods. So
oh, okay.
alive instead. It's the Python. testing.
So alive, set it to true initially, and then we want to kill it at some point. Later it should die, so as it's aging. Yep, so turns true.
False, back to true.
Or you could just say dead.
Okay, dead, false.
Because then you can just keep the same variable.
Perfect. Yeah, so if we had it the other way, we'd have to like do the opposite of true when we call the is dead, because it's supposed to return true if the tree has died. Let's say the tree dies at age 100. Okay, so as it ages the tree, once it reaches 100, just return and it's dead.
Yeah.
So like just
age equal 100.
if self dot age is greater or equals 100, self dot dead.
You have to say greater than or equal to, because one of those test files actually makes it a problem with your age, and you know, not pass that test.
So is that the greater than or equal to? Equals true. So that's off that age.
Or
You
there,
can just do this part of the is dead. Yeah. Does the check like is the age greater than 100?
But what if you don't call that? What if you don't check the is dead?
So you want to.
What if you just age the tree? But we can do that, and we probably should do also additional logic.
That's why
Right,
I think
'cause-
it's alive, because if I said it's alive, then it's continue to age, and I can say continue true, and then it's dead, once it hits 100, I'll kill it off. That's why I did true. It does seem counterproductive, but there's two methods that need two different values to do it.
Interesting. So I think in the test spec, wherever it tells me, see like right here, sorry. So right here, it automatically sets the value of age. So we don't actually run the age tree, so we do have to. So let's do this. If self dot age is greater than or equal to 100, self dot dead equals true, return self dot dead.
So the lines 11 and 12 are also repeated on 17 and 18?
Yes. Yeah, because as we age the tree, like it should die naturally. But in here in our test spec file, we don't age the tree up until we don't execute this age tree. So,
But then we're breaking the rule of don't repeat yourself. Is there a way to not repeat yourself?
I mean,
I don't think you really need that.
this part,
Yeah.
I mean, for the
But
test
the
specs,
tree
you
is
don't.
going to be alive until you run is dead check.
Yeah.
So you kind of need it in both places.
Yeah.
Whether you're checking the age of the tree itself or you just check it. So, redundancy.
But then you can just return, like if the tree is dead on line 12,
Still a
instead of setting, you can just return self.dead status instead of setting self.dead status.
But there's nothing that changed. We have to change it.
You would just be returning false if you need something to actually trigger that change.
So the question is, why do we have to do it here as well as here? Is because if we don't do it here, like in the age tree, if we just set the age tree, can you guys? Thank you. If you just check the is dead, if you're just aging the tree and it gets above 100, it'll never change to is dead until we run this method. And it's not like the logic. We won't always necessarily run the is dead method before the tree gets to 100 years old. And it's okay to, if it's only 2 lines of code that we're repeating, that's fine. It's like big blocks of code that perform the same logic repeatedly. Then you kind of want to break off into your own method. So let's run this. Three tests ran. Great. So it was true. This next test, do we get all these? So is dead, which returns true if the tree has died. Age tree method, age of the tree once a year, goes a little if it's able to grow. Update your test. So if it's, I see this age tree. Okay, if it's able to grow.
Which is what we did for the third tweet. So
Right there.
age past 30, but it's not.
Correct. Update your unit test, test its methods and side effects, implement apple picking. After some years, number of years, you decide the apple starts to bear fruit, write a method, any apples, which returns true if there are any apples on the tree, and false otherwise. Also write a method, pick an apple, which returns one of the apples on the tree, an instance of the apple class. This is important. So when we return an apple, we have to return an instance of an apple class, okay? If you try to pick an apple when there are no apples left, your code should raise an error. Great. The apple class needs to be implemented by this point. Include apple diameter, all right? So we have this apple class. I'm saying right here, we need like an apple diameter, a self.diameter, self.diameter. How do we do, did you guys like set it, just keep the same one?
I imported random and then made the diameter random, rendered from 1 to 6 inches.
Okay, we can randomize each. So how does, what's the
Random dot rendered.
random dot rand int?
Oh yeah, that's it.
Rand.
Parentheses.
Okay.
And then 1,6.
Right.
So you can have a 6-inch apple.
That's right, yeah. Nice big softball of an apple.
I know, right?
Yeah, your mouse are kicking in.
All right, do we have, all right, let's move on to pick an apple. So we have apple, so we create an apple class, an apple instance, an apple tree instance. So we call for in iter tools. I don't know what that is. Repeat none to 10. Don't necessarily, it looks like a for loop that repeats a number of times, and it calls age tree. That's or equal the type apple tree. Oh man, pick an apple should equal the same. So pick an apple should return an apple instance, and this is an apple instance. So the apple tree pick an apple method should also return an apple instance, so like a class object. But how do we make? How do we? Brian Jentz, how do we make an apple? At what point should we create an apple, and where are we going to store these apples on these apple trees?
I don't know if it says after it's like 5 years old, or I don't know if that's just something I looked up again on Google, but when I think apples are considered to be fruit-bearing age.
Okay.
So after they're like of a certain age, we can have them start, I guess, producing apples. And I guess the easiest place to store them would be a dictionary.
A dictionary? Why'd you use a dictionary?
I just figured because you can store in Apple by just using multiple different variables.
Store an apple using multiple different variables.
A list, I mean, you could easily do a list too. It's probably dealer's choice.
Okay. I'm going to do a list. So in order to store apples within the apple tree, we need self.apples equals like an empty array because we want a list. And I think, Brian, you said when after a certain age, the tree will start producing apples. So I'm just looking down here, any apples, pick an apple. Oh, so the most logical place to do it is in when that apple tree ages, so the age tree method. Should we do like another if statement? Self.age is greater than 5. What if the tree's dead? What if somewhere we just decided just to kill the tree like we did up here.
We were talking about drunk lumberjacks.
Yeah.
It's
Thing
great.
you have to be aware of.
So it's greater than 5 and self.dead equals false. So now how do we create an apple? Justin, how do we create an apple?
Yeah, you just create a new instance. So because you've already set up your Apple class, you can just say new underscore Apple equals capital Apple parentheses.
So new underscore apple. So we already set up our apple class. New underscore apple, apple, like that.
Yeah, no, I did a for loop with a random range, so grow a different amount of
Oh,
apples.
nice.
Every
Let's
year.
try that. So, and here for I in range random, what was it?
Yeah, random. I did random int
Dot rand int, like that.
with between 1 and 5.
Does that work?
It's just too random.
Okay, I need it. What else do I need to import?
Tree.
So import random. Is it from apple import apple? So from this apple file, import apple. And fortunately, these two files are located in the same directory. Otherwise, we'd have to manipulate the file path of where this apple file is.
One more line just to be able to add it to the array you created.
All right, so we also need to add it to this apple array. Self.apples dot append new apple.
That's correct.
So I am going to, for fun, I'm going to print self.apples. I'm going to just write some, create a new tree equals apple tree instance, new tree dot age tree. Oh, mess that up. I want to see these apples. Clear. Oh, that's going to work. Python, apple tree. I'm not running the test spec right now. I just want to Pythono. I love Pythono. Oh no. Int is not callable. Oh, age tree. Right? All right. So we have all these apples. These are apple instances, or apple class objects. No, we're just storing them right now. Right up here. We're creating new apples after they grow on the tree. So that now the apple tree has apples on the tree.
Now, Tom,
Yes.
apples, after every year are going to fall off the tree, so you got to start it over. So you want to throw that empty array back
They don't
in.
all fall off. So we need another random.
You want to eat a more than a year old apple?
Touche.
So that's what's fun about building this application. If you want, you can get hog wild with it. Like after so many months or a year, like apples fall off the tree random. Like it's all about building the application. What are the requirements of the program?
Deer.
And whatnot. So yeah, we want we don't need it. That's just how we want to do it.
We're gonna talk about
Yeah.
it. It's called the month.
Oh, okay.
Yeah, it's not. All right, so where are we at? All right, you guys lower the extra commentary, please. So apple, so type of apple tree, pick an apple. So we haven't picked an apple yet. Do we should return any apples? So we haven't run this test. delete this. Clear. 4 tests ran, 1 failure. Apple tree spec, line 36. Any apples? Right in here. So how can I test whether or not there's apples on the tree or not? George, how can I test on whether or not apples are on the tree or not?
Check it. If after you compare that it is comparing and towards that,
So
that is false.
there could never be apples on the tree though. Like what if this random is like 0, or I guess there'd always be, but like there's an easier way to, so just testing it whether it's dead or not.
And after it's comparing, 5.
So when the tree ages, when the age is greater than 5 and the tree is not dead, it puts apples on the tree. And the apples are stored within this list. So how can we test of whether or not there's apples on the tree if the apples are stored in that list? Kenneth.
So we'll just check to see if there's any number in the list, right?
Okay. So if this list has a length,
Then return true.
then return true. If self dot, what is it, apples?
Or would it be len parentheses self dot apple?
Thank you. So if length is greater than 0, return true.
Would we
Oh,
could we shorten the code a little bit if we just say return true if len self dot apples, and it would automatically be a boolean, or would that not work?
so if
Just so like return true if len parentheses self dot apples, else false.
Like apples greater than 0. Just have that.
But I was wondering if we didn't have to say greater than 0, so if we just said if len self dot apples, it would just say.
so the question was, can we shorten this from 4 lines to like 1? So return, what was it?
Return true if len parentheses self dot apples.
Self dot apples.
Else false. One of those things. I don't think you can else if you just on line 30 you just put return false.
On line 30, return false.
Yeah, that's it.
Well, yeah, because of an exit.
So
So I'm trying to else false. We have an if statement.
You can put after the if statement, you can put else false.
Can't you just put a
Just have
boolean?
one line, you can put else false, but that,
here
yeah, it doesn't look very good. It works, I think.
works.
Yeah, that's a ternary.
Yep. So the whole point is to try to make your code as readable as possible for other developers. No, and like if that's great, like this works, it works. Let's keep it. Now does everyone know? So return true if this length, the self.apples list has the length, else false. Let's keep it, it passes. I like it.
Don't try to put a return after else because it will not work. So
Yeah. So as Steven said, this is a ternary in Python. Yeah, I guess return true if this value is true, else return whatever this. Return this value. So pick an apple. When you call pick an apple, it will return an apple object. So apple, age the tree a number of times. So when we pick an apple, it'd be like if length self.apples. Who's the self.apples? Does it just pop? How do we use that? How do we do it? We just want to pop off. So if there is this apples has a length, that means there's apples on the tree. So pop, what it would just be return. Else, raise the exception. I'm not sure if that works. Let's try it. All right, it works.
What is the exception part?
That's when it like raises an error.
Okay, thanks.
So if there's an error in here, or if there aren't any apples on the tree, it's gonna say if this length has a length, doesn't have it, else like essentially raise this exception. Exception's a built-in method in Python that will actually throw an error right here.
Would it be more appropriate to call any apples instead of using if, len, self apples?
Say that one more time.
Should we? I'm just wondering if it would make sense to just do if any apples, just calling the function. If we should do that instead, or if I'm just wondering how you can make it as clean as possible. If that's more considered better practice or worse practice.
There isn't necessarily like that in itself is a great thing. So what if any apples return self dot apples dot pop. Is that right, or is so I need a self within here? So I'm calling, if this is true, this returns true when I call this method, then return dot apples, like pop one off of the list.
We could have done the same in H tree with the is dead when you run an is dead check. That is at the end of every time the tree grows, right?
So do this self dot is dead.
But same the one above it. If we run it there, check if it's dead. Well, you can call the method is dead there itself.
Oh, yeah.
And do the check there instead of running.
So we could also change this line to just execute the is dead method. Could do that. There's a bunch of ways we can do this. I'm going to see if this is going to work. I'm going to clear this down here. I actually have to pick an apple. Or am I doing the type right now? So the type of apple should return. All right, 5 tests ran. So test pick an apple. There you do this. Apple tree. See if this works. Oh, yep. Bring this up here. Six tests ran, 6 tests passed.
When do we want to use the try statement? Is there any
It's
time
just-
that's more ideal than just not bothering with it?
There's not like a right or wrong way when to use it. It's just like readability, and it's just a different functionality that Python has. It's also in JavaScript. There's try except.
But you don't always want to use the try with fix that.
No, not always.
Okay. In my mind, I was putting the two together, so I didn't know.
You can interchangeably use them. It just depends. You'll see them both if you're on the job. You'll see try except. You'll see like try raises and stuff like that.
Like, when you do exception instead of just doing else, like we could have just done like if self
Else except.
or else no apples on your tree or something like that.
Else do something else.
Yeah, like no apples on your tree.
Well, what would we return? So I think this wants to actually raise an exception in the code as like an error.
Return the same sentence. What is no apples in your tree?
See it. I'm not sure. Never done that before.
I think if you just return the string, you don't have to return the exception.
Well, if we just return this, it's checking for the exception. It raises an exception.
Oh, I see.
So the exception. So we can. Oh, didn't work. Oh yeah, so like raise is also. There we go. So it's got to raise an error. I think this indentation is wrong. So yeah, we can actually look at what raise does. Python exception, errors and exceptions. The statement or expression is syntactically correct. It may cause an error when an attempt. So this code is technically correct. Like if it has apples, well, so that's actually kind of good. So this actually will never, oh no, it'll raise. So generally, like if a line of code is like syntactically correct, but for whatever reason, like there's nothing in a list, then you're trying to run a method on a list, then it's going to raise an exception. That's what the exception is for. Like if you're trying to append something to an index that doesn't exist in an array, like technically from a syntactical perspective, your code is correct, but it doesn't have access to the index. It's like your list doesn't contain an index. Ah, shit. Sorry, I just shut off the power to the something. I just shut off the power to my workstation and everything. So, does anybody have any questions on with regards to apple tree?
I had a question about just like calling functions that return something within a conditional statement. Is that fine to do if you, just as long as you're returning something, I guess a value, kind of like how we just call the any apples function within that if statement?
Yeah, that's okay. I think so. I've seen it done in JavaScript and here. But then again, it's all about readability for another developer. Is this the best? Because like, if I just do like, oh geez, if length of self dot apples, so if that's true, is it greater than 0? That's like really easy for me to understand what's going on. Like, oh, okay, if the length of apples is greater than 0, then run this. Otherwise, if it's like, it's the other way. It's like, okay, if any apples, well, now I got to go check on what this function does. All right, it's got to come up here. Oh, okay, all right, if return true if length of apples. Oh, okay. So it's just like another step the developer who's reading the code has to go through. Any more questions? Great, I'm going to stop the recording right there if I can somehow do it. Where are you?